Cryptography is the practice and study of techniques for secure communication. It is the science of writing in secret code. Cryptography is used when important communications are sent over any uncertain medium, such as the Internet. Cryptography ensures that the message reaches the intended person without being intercepted by a third party. Using a certain set of rules, a readable message is converted into a coded message. The set of rules is called the key. Only those who know the key can convert the coded message back into a readable state. Therefore, cryptography ensures a secure communication over an untrusted medium. The first documented use of cryptography dates back to the Egyptians in 1900 BC. The primary use of cryptography was for diplomatic and war-related information. During that period, cryptography was very primitive in nature. However, it was extremely effective in preventing information from being intercepted by the enemy. Roman Emperor Julius Caesar is credited with the invention of one of the simplest but most widely used forms of cryptography known as Caesar ciphers. Julius Caesar used a technique of shifting the letters of the alphabet. Caesar ciphers will be discussed in detail under the topic of secret key cryptography. Although the use of cryptography dates back to 1900 BC, it was not used widely until World War II. Highly classified and war-related information communications were transmitted in a digital form, and there was a high risk of those communications being intercepted by the enemy. Although there was an extensive use of cryptography during World War II, cryptography was not common in our everyday world. The breakthrough came in mid-1970 when open academic research on cryptography began. Extensive use of mathematics, including statistics, abstract algebra, and number theory, gave rise to highly complicated rules in cryptography. Such research made cryptography much more reliable and secure. To understand how cryptography works, we need to familiarize ourselves with the following terminology: plain text, encryption, keys, ciphertext, and decryption. Plain text is the readable message. Encryption is the process of converting the plain text into the coded form used by the sender. Keys are the set of rules used for encryption. The plain text that is encrypted into coded text form by the use of a key is called a ciphertext. The process of converting the ciphertext into readable text to be used by the receiver is called decryption. Cryptography is categorized into three types based on the use of keys for encryption and decryption. These three types of cryptography are secret key cryptography, public key cryptography, hash function. Secret key cryptography is also known as symmetric cryptography. It is a traditional form of cryptography. A single key is used for both encryption and decryption. The sender uses a particular key to encrypt the plaintext and sends it to the receiver. The receiver applies the same key to decrypt the message. Since the key is shared between the sender and the receiver, it allows for relatively fast communication. However, secure exchange of the key between the sender and the receiver is the main problem in this cryptography. The first and foremost thing in cryptography is to generate the key. As mentioned earlier, Julius Caesar derived Caesar ciphers by shifting the letters of the alphabet. In this example, the letters of the alphabet in the plain text are shifted by 3 to convert into the cipher text. The derivation of the key looks simple, but it was very effective in conducting a secure communication. The table shows how the plain text is converted into cipher text by shifting the letters of the alphabet by 3. A simple example below will help visualize how it works. Ben, a commander of Big Boy's battalion, has to send an important message to other commanders once in a while without letting the enemy intercept the message. He holds a meeting with other commanders and informs them to use the following key for the encryption and decryption. Here, A in plain text will be represented by I in ciphertext. Other letters follow the pattern as shown in above table. There is a shift of 8 here. If Ben wants to send a message to inform that the place is insecure, he will encrypt the message as QVAMKCZM. Except for the commanders who know the key, no one will have any idea what the message says. The commanders on the receiving side can use the same key as shown above to decrypt the ciphertext to plaintext. The example given above is very simple and can be easily decrypted by a third party. Even though it looks very simple, this is the basic idea behind public key cryptography. Varieties of ideas are used to develop more sophisticated keys. One of such is substitution. The idea behind the substitution technique is the same as in Caesar ciphers, but instead of shifting, substitution of the alphabet is done. Ciphers generated by this method are called substitution ciphers. Here, A in the plain text is represented by Q in the ciphertext. Changing the substitution can generate numerous keys. With 26 alphabets, 26 factorial is 1 times 2 times 3 times 4, etc. is equal to 4.032 times 10 to the 26th power ciphers can be generated. Public key cryptography, also known as asymmetric cryptography, is more advanced and hence more widely used. Public key cryptography involves 2 sets of keys. The sender uses one key for encryption, whereas the receiver uses a different key for decryption. The receiver creates 2 different sets of keys, one public key, which anyone can see, and one private key which only the receiver knows. Anyone who wants to send encrypted messages to the receiver has to use the public key of the receiver. Public key cryptography depends on one-way functions. Keys in public key cryptography are based on mathematical functions that are easy to calculate, but their inverse functions are relatively hard to determine. The generation of private key and public key is complicated because it requires the mathematical knowledge of abstract algebra and number theory. Much more complicated functions are used to develop public and private keys and hence ensure a secure communication. Hash function is a procedure that turns plain text into a fixed size code that is called hash value. Hash value is called message digest or simply digest. Different plain texts have different hash values and hence are unique. A slight change in the text will result in a change in the hash value. Hash function has been a key concept behind authentication. Passwords that are entered in online accounts, PIN codes that are used in ATMs, and digital signatures that are used in online transactions are all stored in the form of hash function. Hash function is also used in fingerprint identification and all other forms of authentication. Coding and decoding is not only used for secure communication. Braille is the best example of coding and decoding that is not used for secure communication. Braille is a method of reading and writing that is used throughout the world for people who are visually impaired. Louis Braille devised it in 1825. It is a form of coding where a defined set of rules are used. Before going in depth, we must know the basic idea behind Braille. Each Braille character is made up of 6 dots, 2 columns consisting of 3 dots each. The unfilled dots represent a space and the black dots represent a raised bump in the Braille. With the use of 6 dots, a defined set of rules have been developed. The following picture summarizes everything. Braille is a form of cryptography that uses a single defined set of rules throughout the world. With the help of the table, the plain text can be converted into ciphertext and vice versa. This is a second table that will help with conversion.